I thought this video was really cool because it explores the local universe. By local, I mean the region around us out to about 370 million light years. This is local by cosmological standards. The original video was called The Cosmography of the Local Universe, produced by a group of astronomers in 2013 in the Astronomical Journal of the American Astronomical Society. The URL to the video is in the class notes. I have edited it here to shorten it up considerably and to add my own narration that is hopefully more understandable to lay people. The video takes the results of an astronomical catalog called the V8K Redshift Catalog. Redshift refers to the light stretching out due to the doppler effect and the stretching of space due to cosmic expansion. As the light stretches out, it shifts toward the red end of the spectrum. This shift in an object's color correlates with its speed away from us. Thus, V8K means the recession velocities of the objects in the catalog are all 8,000 kilometers per second or less, which for us Americans is 18 million miles per hour or less. Using Hubble's law, there is a correlation between the redshift and the distance from us. 8,000 kilometers per second corresponds to a distance of 372 million light years, which is less than 1% towards the edge of the visible universe. This picture views the entire sky as seen from Earth, mapped onto an oval so we can see it all on a screen. Something similar is done with maps of the Earth. Each dot is a separate galaxy, and its color represents the speed away from us. Blue dots are the slowest and thus are the closest galaxies to us, and the red dots are the fastest and thus the farthest from us. Let's plot these galaxies in three-dimensional space. Note the bluest are in the middle and the reddest near the periphery. Where are we in all this pile of points? In the center, of course. Let's find the Milky Way. The Milky Way is shown as a blue dot in the middle of the crosshairs. The Milky Way and its entourage and the Andromeda Galaxy and its entourage highlight the local group. Other galaxy clusters are also contained in this cube, roughly 40 million light years on a side. There is some structure to these groups, including something called the local void and the local sheet. Zooming out further, we include a dense galaxy cluster called the Virgo cluster, which means it is in the direction of the Virgo constellation in our night sky. Now we zoom out to the width of the entire V8K catalog, 740 million light years. But the depth of the slice is only 92 million light years into the screen. Note the item called the Great Wall near the top of the screen. Next, let's look at a section cut about 46 million light years thick. You may note bubble-like voids with galaxies concentrated in the filaments and nodes between them. Here's another one rotated 90 degrees from the first. Note again the filaments and nodes of galaxies. It is assumed that not all galaxies in the 744 million light-year cube are in the V8K catalog, since the farther away the galaxy is, the harder it is to see. An attempt to estimate the missing galaxies based on the presence of known galaxies is made and shown here as density contours. Note the structure we saw earlier called the Great Wall. Lastly, an attempt is made to infer the motion of galaxies relative to each other, once the cosmic expansion is factored out. First, the deviant velocities away from us are shown as arrows. Red is always from us and blue is toward us. Deviant refers to the departure from Hubble's law. Notice the bulk of the arrows point to the left, indicating a great something is pulling the galaxies and clusters of the galaxies in the local region towards it. Next, statistical techniques coupled with inferred mass distribution are used to develop streamlines for the flow. Finally, the streamlines are animated to show the flow of galaxies to the Great Attractor. According to Wikipedia, the Great Attractor is a gravitational anomaly in an intergalactic space. The observed anomalies suggest a localized concentration of mass millions of times more massive than our Milky Way. However, it is inconveniently obscured by the disk of our galaxy.